All right, we are going to go through the solutions review, this sheet. So here's the first question. Explain in terms of molecular polarity why ethanol is soluble in water. So I'm using the Edge browser, so I have these PDF tools. So explain in terms of molecular polarity, so I'm going to extend it to here, why ethanol is soluble in water. So I got to talk about polarity, right? So water is polar if ethanol does not dissolve in water, it must be non-polar. That's it, okay? All right, so let's look down here. Each salt below is dissolved in water. Write the dissociation reaction for each electrolyte. Remember, electrolyte is something that conducts electricity when it is dissolved in water. Write the total number of ions that form because of the dissociation on the line, so over here. Use the example for help. So here's one. Calcium bromide as a solid, and remember in this reaction we are just dissolving it in water. It breaks apart into its component ions. Calcium with a 2+ charge and bromide with a -1 charge. Why do I put a coefficient of 2? Because this subscript meant there were 2 of those ions. So I had 1 calcium and 2 bromide, which gives me a total of 3. All right, so let's try this one. Well, here is what's going to help me for this. I'm going to go to reference table E. So you see right here? Because this has more than 2 elements. So that means something has to come from table E. So I have KHCO3. So I'm going to go back here and look for something that there's HSO4. No, that's not it. Oh, here we go. Do you see it right here? HCO3. That's hydrogen carbonate. I need to know the charge. It's negative. Okay, so let's go back here. So that tells me that the -1 is HCO. And that is going to be 3, well, you know what, I'll draw the next part. HCO with 3 and a negative charge, okay? And then for K, all right, how would I know what its charge is? Let's review. I'd have to go to the periodic table. Let's just rotate, oops. Rotated too many times. All right, rotate, let's zoom in. And here is K over here. And you see its charge +1. So let's go back here, so that's plus. That's it. There are no other subscripts. This subscript of 3 right here did not indicate there was 3 of them of the whole ion. It just meant that there are 3 oxygens in that ion. So I only have 2 ions. All right, so let's look at the next one. So I have this in parentheses already that tells me automatically go to table E. So when I do, what do I find? Oh, here it is right here. C2H3O2, that's what I need. The charge is negative. Okay, so I need C2H3O2 with a negative charge. How many of them do I have? Well, this 2 is outside the parentheses. That means I have 2 of them. Okay, now technically for each one of these, I should indicate that it is aqueous, right? It is dissolved in water, right? So that should be after each one. So this is aqueous. What else do we have? Well, we have Fe. What is the charge of Fe? If we go to the periodic table, it has 2 options. But remember, this was -1, and I have 2 of them. So I have a -1 and a -1. So this would have to be +2. So it would be Fe2 positive aqueous. So how many total ions? This time 3. 2 of these and 1 of these. All right, next I have A, L, and O. That's an easy one to start with because I just have 2 elements, right? and I know they're going to be aqueous. They're going to get dissolved in water. All right. I know based on this subscript that I have 2 aluminum, and based on this subscript I have 3 oxygen. So I know I have 5 total ions. All that's missing is the charge. So let's go for aluminum, positive 3, oxygen, negative 2. So 3 plus 2 negative. All right, last one. It has 2 elements, H and Cl. I know it is going to be aqueous. I know it is going to be aqueous. All right. I know there are no subscripts, so there's 1 of each. I just need charges. All right, for hydrogen and for chlorine. Now, they both have more than 1, but when chlorine is in a compound, it's the last one. We use the negative one, which means if this is negative, this must be positive. So I have 2 total ions. All right. So now let's look at this one. A scientist makes a solution that contains 44.0 grams of hydrogen chloride gas and 200 grams of water. Based on reference table G, identify in terms of saturation the type of solution. So now I need to go to table G. All right, here we go. So we're on this question and it says reference table G. So here's reference table G. What substance do I need? HCl. So let's find HCl. That line is right here. Okay, so do you see right here? There's HCl. Okay, now here is what it says, 200 grams of water. But you see this reference table requires 100 grams of water. So what I need to do first is how many grams did I add? 44. So it's 44 grams, but I had 200 grams of water. In order to read it off the graph, I need to know how many is in 100. So I can cross multiply. What I'm going to get is 22 grams. Half as much water, I use half as much of this. Okay, so I go back to my graph, and what was my temperature? 20 degrees Celsius. So I go to 20 degrees Celsius, and I go to 22 grams, and I'm going to put a point there. Okay. Now I'm going to compare that point to this HCl line. Is this point under the line, is it on the line, or is it over the line? Well, it is under the line, so that means this would be unsaturated. All right, next question. In a laboratory, a student makes a solution by completely dissolving 80.0 grams of KNO3 in 100.0 grams of hot water. The resulting solution has a temperature of 60 degrees Celsius. The room temperature in the laboratory is 22 degrees Celsius. Classify in terms of saturation the type of solution made by the student. Well, you see, this time we do have 100 grams of water. So I need to find 80 grams of KNO3 at 60 degrees Celsius. All right, so 60 degrees Celsius, 80 grams. There's my point. And I was comparing it to KNO3. Well, here's KNO3. This point compared to KNO3's line means I am unsaturated. All right, compare the boiling point of the solution to the boiling point of water at standard pressure. The boiling point of the solution is higher than the boiling point of water. Remember, boiling point goes up and freezing point goes down when you have a solution. Describe the direction of heat flow between the solution made by the student and the air in the laboratory. Well, the air is 22 degrees Celsius and the solution is 60 degrees Celsius, and heat flows from warmer to colder, so heat will flow from the solution to the air. Okay? And then describe a laboratory procedure that can be used to recover the solid solute from the aqueous solution. Evaporation, right? If we evaporate the water, we will be left with the solute. What mass of KNO3 dissolves in 100 grams of water at 40 degrees Celsius to produce a saturated solution? Okay, so I have 100 grams of water. Here's my temperature. Here's my substance. I need to know the mass. So I have 40 degrees Celsius. My substance is KNO3. So I'm going to go up from 40 until I hit KNO3's line, right? So right here. Okay? And then I'm going to go across and read that in grams. So like 64 grams about. Okay? 64 grams. Determine whether the following solutions are unsaturated, saturated, or supersaturated. So first one has 100 grams of water. So 50 grams of KCl, 60 degrees Celsius. So 60 degrees Celsius and 50 grams. So 60 degrees Celsius and 50 grams. There's my point. What am I comparing it to? KCl. So where is that point? Oh, it is above KCl's line. So that makes it super saturated. All right, next one. Oh, I have a problem. 200 grams of water. So I have 140 grams per 200 grams of water, but the graph requires 100 grams of water, so that means 70 grams. So I need 70 grams at 10 degrees Celsius. So 10 degrees Celsius, 70 grams. And I'm looking at Ki. So where is Ki? Well, it's all the way up here, right? So it is under that. Now look, if it was NH3, it would have been saturated because it's on that line. But for comparing it to Ki, we are unsaturated. And then 40 grams of NaCl and 50, ooh, look at this, 50 grams of water. So if I have 40 grams of the solute and 50 grams of water, but I can't read the graph unless I have 100 grams of water, then this ends up being 80 grams. So 80 grams at 90 degrees Celsius. So 90 degrees Celsius, 80 grams, that's all the way up here. Here's NaCl's line, so that is definitely super saturated. That is way above the line. Okay, super saturated. At what temperature do KCl and HCl have the same solubility? So KCl right here, HCl. So where would they have the same solubility? Where their lines cross, which is right there, which that is about 76 degrees Celsius. Right? Which of the salts in table G is least soluble at 90 degrees Celsius? Well, 90 degrees Celsius right here, least soluble. Well, SO2, but that's not a salt. NH3, but that's not a salt. There we go, NaCl. So for that one, you just had to be careful because it was asking you about a salt. And those first two were covalent, so they were molecular compounds, not salts. And then which salt on table G shows the least change in solubility between 30 degrees Celsius and 70 degrees Celsius? So between 30 and 70, which one changes the least? And it is which salt, right? So SO2 also doesn't change very much, but the salt is NaCl again. At what temperature will a solution containing 60 grams of NH4Cl in 100 grams, I like that, of water be saturated? So I'm going across from 60 grams until I get to this line. So 60 grams, and I need to go across, keep going, keep going. Here's NH4Cl, so right here. And then I'm going to go down and read that temperature, so like 67 degrees Celsius. Alright? Alright, so calculate the molarities for the following solutions. So here is the molarity formula. So molarity, that's its symbol, equals moles of solute over liters of solution. So moles of solute over liters of solution. Do that in a calculator, 0.5 molar. Moles of solute divided by, this is milliliters, so 600 milliliters, right? To change it to liters, I take the decimal and I move it 1, 2, 3. So 0.600. So then you take your calculator, right? And you do 4 divided by 0.600. Equals 6.67. Okay, so we're going to do 6.7 molar. Now next one, we need moles over liters. Well, we got liters, that's beautiful, right? But we have grams, not moles. Okay, so you have to remember that you can do this. So moles is mass over gram formula mass. So moles equals mass over gram formula mass. So I have the mass, 2.2. Gram formula mass. What do? I look up these elements. The atomic mass or molar mass for carbon is 12. For oxygen it is 16. But I have 2 of them. So that's 32, and then I add them up. 32 and 12 is 44. So I need to do 2.2 divided by 44. So 2.2 divided by 44 equals, so I have 0.05 moles, and that's how many liters I have. So I take that number and I divide it by 0.010, and that gives me 5. So it is a 5 molar solution. And then we have moles, good, 3.15, terrible 5, divided by, oops, I need to change this to liters, right? So move the decimal 3 places, 0.250 equals, so 3.15 divided by 0.250 equals 12.6. So 12.6 mole. All right, next one is parts per million. So we're going to use this formula right here. So mass of solute divided by mass of solution times a million. Okay, so it is solute over solution, the mass of solute over mass of solution times a million. Don't forget that. 1 with 6 zeros. All right. So we have a 0.00074 grams of hydrogen cyanide, and we have a 3.2 gram sample of air. So that's the whole sample, and that's the part that is hydrogen cyanide. And then 1, 2, 3, 4, 5, 6 zeros equals. So how do I do this math-wise? Okay, well, let's see. Let's just, there we go. Move it on this side. Okay, so we have 0.00074 divided by 3.2 equals times 1, 1, 2, 3, 4, 5, 6. There's a million equals. So 231 ppm parts per million. Okay, so just making sure. Yep, I'm just making sure I put enough zeros in the 2 point in this before the 7.4. All right, so if 3 grams of salt are mixed in with 450.0 grams of water, what is the concentration of salt in the solution in parts per million? So the solute is the salt divided by the solution. Well, this is just the water part, but the solution includes the salt, so it is 450 plus 3. So actually it's 453 grams. Divide those and then times 1, 2, 3, 4, 5, 6 zeros. Okay, so let's look at our calculator again. If I can move it on this side. All right, so I have 3.0 divided by 450. Nope. See, I almost did it wrong. 3.0 divided by 453 equals times 1, 1, 2, 3, 4, 5, 6 zeros. Whew, that's a lot. So 6,623 parts per million. All right, so now a solution contains 25 grams of KNO3 dissolved in 200 grams of H2O. Calculate percent by mass. All right, so now I got to go back. This formula right here. It's mass of part over mass of whole times 100. So it's part over whole times 100. The part is 25 grams. The whole thing is the 200 plus the 25, because that just says water. So it's actually 225 times 100. So let's do that math. 25 divided by 225 equals times 100 equals 11.1%. All right, a solution is made by dissolving 70 grams of KNO3 in 100 grams of water. Show a numerical setup for calculating the percent by mass. So I don't need to do the whole thing, I just need to set it up. So what is the mass of the part? 70 grams. What is the mass of the whole thing? The water and the KNO3. So 170. But then I can't forget the times 100. And that's done. I could do this. Just 70 divided by 70 plus 100 times 100. And that would be fine. Okay. All right, we're on our last question. A total of 1.4 moles of sodium nitrate is dissolved in enough water to make 2.0 liters of an aqueous solution. The gram formula mass of sodium nitrate is 85 grams per mole. Write the chemical formula of the solid. Well, it's sodium nitrate. Sodium is Na plus, nitrate from table E. So I would go to table E, right? And you find nitrate right here. Okay, NO3 negative. So NO3 negative. Well, those charges balance, so I just write Na, N. Very done. Show a numerical setup for calculating molarity. So do you remember molarity is moles divided by liters? Do I have moles? Yes, 1.4. Do I have liters? Yes, 2.0. Done. Okay. Next one, I'm going to type this one. Compare the boiling point of the solution at standard pressure to the boiling point of water, H2O at standard pressure. The boiling point of the solution is higher than the boiling point of water, right? The boiling point of a solution, because of the solute, is higher. If it was freezing point, it would be lower. And then calculate the molarity. So I set it up, so then I just have to do the math, right? So 1.4 divided by 2.0 equals 0.7. 0.7, my units, capital M, molar. And there we go. That is our review. The only thing we didn't go over, which we did some classwork with, and there will be some in the other piece of review, is table F. So remember, the rule on this side is soluble. The rule on this side is insoluble. But remember, insoluble means just a little bit of it dissolves. When there's no exceptions, that's super easy. Okay. Don't forget, for group 1, that's not all of those in group 1. So you have to check. The halides are group 17, and actually they're not all here either, so be careful. Right? So if it follows the rule on this side, it's soluble. If it has an exception, it breaks the rule and it becomes insoluble. If we're talking on this side, if it follows the rule, it's insoluble. If it's in the exception and breaks the rule, it becomes soluble. All right, but we will do more practice with that, and in the other piece of review, you will see that. Okay.